Good morning. Today we'll start again Fourier transform, but this time we are not going to explain too many things. We'll give you some gift, which is exercise solutions. Okay? Just a reminder, this is a symbol of Fourier transform, and this is a symbol for inverse Fourier transform. Again, Fourier transformation moving the function of time to be a function of frequency. The inverse Fourier transform moving the function of frequency into a function of time. Here is the formula for Fourier transform. The Fourier transform is, I'm not saying typically like Laplace transform, but it is becoming because Laplace transform fail to integrate from minus infinity to infinity. Okay, for example, we have a temperature, and the temperature, if it is an independent variable, it has a negative temperature and positive temperature. So how it comes using Laplace transform? Laplace transform has integration from 0 to infinity, so your independent variable x or t must be start from 0 and above. This is the inverse Fourier transform. Also, there are some properties for Fourier transform, linearity, and you can find Fourier transform for the limit. This is what does it mean, linearity. It means if you have a constant, you can take it outside because it is integration, the formula of Fourier transform. And also, if you're adding two functions together, you can find the Fourier transform for the first one plus the Fourier transform for the second one. If you have a derivative, exactly like Laplace transform, you have something outside the Laplace for the original one. In Laplace, you have S outside. In Fourier series, you have I omega. So you will see roughly I omega instead of S in all the Fourier transform if you compare it with Laplace transform. Again, this is the Fourier transform. This is the Laplace inverse transform. As I said, Laplace transform is working for the independent variable between 0 to infinity, but Fourier transform is working between minus infinity to positive infinity. Yes, we use Laplace transform in finding the solution of the independent for the LRC mathematical modeling, and also for finding the current in each loop. Okay, because we know in such case we have the time greater than or equal to 0. But as I said, if we have a temperature, and the temperature may be negative or positive, like the heat equation, which is not ordinary differential equation, it is partial differential equation. So we need something to have the integration from minus infinity to infinity, which is Fourier transform. So Laplace transform is solving ordinary differential equations, such as finding the current in RLC circuit, because it depends on the time, so the time is always 0 or positive. But when we go for the wave equation or heat equation, we have negative and positive, so we are going to use Fourier transform to solve its mathematical model. In this case, it is a partial differential equation. Yes, you have a table for Laplace transform, and also you have a table for Fourier transform. So no need to integrate all the time if you have your function from one of the Fourier transform table similar to the Laplace transform table. Also, you can find the inverse of Laplace transform if you know the frequency function, right? You can go to the original function, which is the inverse Laplace Fourier transform. Here is the exercise. I ask you to solve number 9, but unexpectedly only 11 out of 30 submit at the time. Okay, so we have to do something today to solve this one. Okay, we get back to solve number 3. So your function f of x is 1 between a and b and 0 otherwise. Before we start, we have to know the formula. The question was what? Was find the Fourier transform. Find Fourier transform. Okay. Find Fourier transform for this one. Before I start solving the question, I have to know what is the formula I'm going to use this one. Okay, the Fourier transform for any function f of x or f of t, doesn't matter, is 1 over root square of 2 pi integrating from what to what? From minus infinity to positive infinity for my function f of x or f of t, doesn't matter, e to the minus what? E to the minus, yes, I omega x. I hear you. Some engineer boxes they're using j instead of I, omega x, and you integrate with respect to x to have your Fourier transform should be a function of omega, right? This one, it will be becoming function capital F of omega, right? So let us substitute by our function. Okay, what is your function in this case? Your function is defined between a to b, so you're integrating from a to b. Okay, your function in this case is 1. Okay, and this is the constant part, or the fixed part, sorry, in Fourier transform. Sorry, I missed dx here. Okay, so it is easy integration. Okay, now how I can integrate this one? 1 times anything is 1. The integration of exponential function is the same exponential function divided by the derivative of this one with respect to x. So the derivative of this one is minus I omega. Okay, and don't forget we substitute from a to b where the function is defined. Okay, now let's substitute. Yes, this is my Fourier transform, which is a function capital F of omega. Okay, this is difference from the Fourier symbol. Okay, now if I substitute by b, I have e to the minus I omega b over minus I omega. Okay, minus e to the minus I omega a over minus I omega, right? This is my substitution. 1 over root square of 2 pi. Okay, now this minus times this minus, it will be plus, right? But it is better to take minus outside, and this is e to the minus I omega b. Yeah, so I can take, I don't accept I in the numerator, if you remember, in the complex numbers, so I have to multiply by I in the numerator and I in the denominator, right? So when you multiply by I, what do you have here? You have I times I minus 1 times minus 1, so it will be positive omega, right? And don't forget this one outside here, over root square 2 pi. Also, when this one, it will be as it is. Okay. And minus. I said I times I is minus, and you have minus will be plus, so you still have omega e to the minus I omega a. I finish my work. Okay. Also, you can take this omega outside. This is the final result of my Fourier transform for the function defined by 1 from a to b and 0 otherwise. So this is the formula for Fourier transform, having integration from minus infinity to infinity. I have nothing outside the interval a and b, so I'm going to integrate only from a to b. Of my function is 1 e to the minus I omega x. This is a fixed part in the Fourier transform. How to integrate the exponential function? You have the same exponential function divided by the derivative of the exponent of e with respect to x. So yes, I have to divide it by minus I omega. Now I have substitute by b first, minus the substitution of a. I don't accept I in the denominator as a complex analysis says, so I have to multiply by I in the numerator and then denominator. So when you multiply by I divided by I, you do nothing because this is 1, just to get rid of the I in the denominator. Okay, this is the Fourier transform for our function. Clear? Solve number 4. Here is number 4. Just to solve number 4, again, I wish all the time to remember the formula of Fourier transform. Also, when I am solving any question about Fourier series, I have to write the Fourier series. Okay, so what is the formula again? This is the Fourier transform for f of x is equal to 1 over root square of 2 pi, integrating from minus infinity to positive infinity for my function, multiply by the fixed part of minus I omega x and integrating with respect to the independent variable x. If you have t, you can replace it by t. This is the formula of Laplace transform again, just to remind you. Okay. Let's try to substitute in this one. So the Fourier transform for my f of x is 1 over root square 2 pi. Yes, my function is only defined when x is negative, so I can integrate from what to what? From minus infinity to 0, and my function is defined as e to the kx. Okay, and here is the fixed part, e to the minus I omega x dx. Okay, but what about 0 to infinity? Because my function is 0, so yes, if you would like to type it, that's fine, from 0 to infinity, and your function is 0, e to the minus I omega x dx. This is what? This is 0. Okay, fine. Now let's go a little bit further to integrate this one. Okay, my Fourier transform for my f of x equal to 1 over root square 2 pi. What is the integration of this one? First, I have to multiply this one by this one. So don't be in a hurry, take your time to get the right answer. So e to that, I can take x as a common factor, so I have k minus I omega, and I have x outside. Why I take only x? Why I didn't take minus x? Sometimes you take minus x, because I already have minus infinity to substitute, because e to the minus infinity will be 0. Okay, but the case when you have from 0 to positive infinity, you take minus x outside just to have e to the minus infinity, right? Okay, now what is the integration of this one? As I said many times, the exponential function is integration is the exponential function itself divided by the derivative of the exponent here, which is k minus I omega, right? And don't forget your lower bound and your upper bound, but you are going to substitute by the upper bound first, right? Okay, now let's go to do this one, 1 over 2 pi. Now when you substitute x equal to 0, you will have e to the 0, right? Okay, over k minus I omega. Okay, sorry about that. Minus, when you substitute by minus infinity, I said e to the minus infinity, okay, over k to the minus I omega. E to the minus infinity is 0, e to the 0 is 1, so I end up with what? I end up with 1 over root square of 2 pi. This is 1 over k minus I omega. Again, I'm saying I am not going to accept any I in my denominator. So what you have to do, I have to multiply by the conjugate to get rid of this one, okay? So this is equal to 1 over root square 2 pi. I have to multiply by the conjugate, so it's k minus I omega. What's my conjugate for this one? The conjugate will be, you just change the sign of I, k plus I omega. And also you multiply the numerator and the denominator, because this is equal to 1, so you change nothing in your question, okay? Now when you multiply this one, this is a square difference, right? So which is k square minus I omega square, right? Over k to the plus I omega, and you have 1 over root square 2 pi here. Okay. Now I squared is minus 1, and you have minus here, so it will be positive omega square, and this is will be k square, and you still have here 1 over root square 2 pi. Okay. So I finish. This is my Fourier transform for my function f of x. Okay. Clear? I hope so. Okay, we will start to solve number 6. Again, in the beginning of the solution, I have to write the formula I'm going to use. What is the formula? The formula of Fourier series, because the question find Fourier series. Find, Fourier transform. Okay. Now again, Fourier transform for f of x is equal to 1 over root square of 2 pi, integration from minus infinity to positive infinity for my function, multiplied by the constant part e to the minus I omega x dx. Okay. Yes, I can integrate from minus infinity to infinity because he's telling me my x from minus infinity to infinity. But I have a problem with the absolute value of x. What is the absolute value of x first? The absolute value is positive x when x is equal 0 or above, and minus x if x is less than 0. What about minus absolute value of x? Minus absolute value of x. It will be what? It will be minus x, okay, and this will be positive x. Are you going to change this one or not? This is my point. Okay? If you can go for Desmos and you graph this one, right? I know the exponential function starts like this one. This is e to the positive x, right? What about e to the minus x? E to the minus x will be what? If x is 0, it is 1. E to the minus 1. What is e to the minus 1? 1 over e, right? 1 over e. E is 2.7 something. So 1 over 2 point, it will be less than 1, right? So instead of going up, you will go down, right? Okay? So please try to solve this one, to graph this one using Desmos. So this is e to the x. Okay? What about e to the minus x? How to graph e to the minus x? If x is positive, okay, so you will have, you increase this one, right? Yes, you will start from 1 and you go down, right? Is it? Do you think that the value of function e to the minus x will be negative? No. E to the x is always positive, even x is negative, right? This is very important to you to know, right? So, yes, I am going to go in the other side here, like this one, okay? Yes, when you have a big negative value, okay, like 1 minus 100, so you have 1 over e, e to the minus 100 will be 1 over e to the 100. 1 over e is less than 1, right? Okay? So when you get bigger one, you have a small number, right? Again, let's back to this one. So this is, I don't care about this one. I'm caring about the integration from minus 0 to infinity. So my Fourier transform will be the 1 over root square 2 pi, the integration from minus infinity to 0. Okay? What is my function in this one? I know the minus absolute value of x. I know the absolute value of x in the negative is minus x, and I have minus here, I will have positive, and I have this fixed part. Okay? Plus the integration from 0 to infinity for the function from 0 to infinity. From 0 to infinity, it means x is positive, right? When x is positive, the absolute value of x is x, right? And I have minus outside, so it will be e to the minus x. And this is the fixed part of Fourier transform. Okay? Now, my Fourier transform will be 1 over root square 2 pi. Okay? What is the integration of this one? Again, I multiply this one by this one. In this case, I have minus infinity, so I can take x as a common factor again. So it's minus infinity to 0. For e, I can take x as a common factor. So when you take x from here, you have 1 minus I omega, and you can take x as a common factor. Dx plus the integration from 0 to infinity. Here, minus minus, and remember you will substitute by positive infinity, so you take minus x outside as a common factor. Minus x outside as a common factor. When you take minus x from here, you still have 1. When you take minus x from here, you have plus I omega dx. Okay? Now, what is the integration of the exponential function? Again, I'm just remind you. The integration of exponential function is the same exponential function divided by the derivative of this one. As I said, this is constant, so when you have a constant 5x and you differentiate it, you have 5. So this is exactly like the constant like so you divide it by 1 minus I omega. Don't forget, in this case, you divide, your lower bound is minus infinity and your upper bound is 0. Plus, the same case here, you have the exponential function divided by the derivative of the exponent, which is a constant, this one. But remember, you have minus outside, so you have minus 1 plus I omega. And don't forget, your lower bound in this case is 0 and your upper bound is infinity. Okay? Now, substitute. If you have x equal to 0, you have e to the 0, right? When you have x e to the minus infinity, you have e to the minus infinity. Why I'm writing minus here? Because the substitution of the upper bound minus. And I have this is as a common denominator. Okay? So this is a substitution. Plus, I will do this one here. When you substitute by infinity, you have e to the minus infinity. Minus, when you substitute by 0, you have e to the 0 over minus 1 plus I omega. Don't forget 1 over root square 2 pi. Okay. Now the final result will be 1 over root square 2 pi. Again, e to the 0 is 1, e to the minus infinity is 0, e to the minus infinity is 0, e to the 0 is 1, right? So what do you have here? You have 1 over 1 minus I omega. Okay. Plus, this is minus e to the 0. So, and because this is 0 minus 1, so you have minus 1 over minus 1 plus I omega. Okay. This minus will be cancelled out with this minus. Okay. Now I have the common denominator, okay, which will be 1 minus I omega times 1 plus I omega, okay. And when you have this one divided by this one, you have the other one, I omega. When you have divided this one by this one, you have 1 minus I omega, 1 minus I omega. Now, this is a square difference, right? So, your final result will be 1 minus I omega and the I omega square. So, I square is minus 1. Minus will be positive, so you have 1 plus omega square. Okay, omega square. Okay. And up here, you have plus I omega and you have minus I omega. You cancel out this together, so you have 2. This is your final result. Please, if you have any question, please ask.